In this video, we're going to do some insurance problems. Now, the entire insurance industry is essentially based on this idea of expected value. And calculating expected value is very important in determining how much insurance companies charge for their product. So in this first example, we are insuring a car video system for $2,000 against theft. And we're paying a premium of $225 for coverage for 1 year. The insurance company says that the probability is 1/10, 0.1, that the system will be stolen sometime during the year. What is your expected return from the insurance company if you take out this insurance? We're going to complete this payoff table to help us calculate it. Now, an important thing here when you're doing insurance problems is that you are paying the premium, in this case it's $225, regardless of whether or not you use the insurance. So that $225 is gone in both cases. So we know that the probability of the system being stolen is 0.1. That means that the probability that the system is not stolen during the year is 0.9, because it's either stolen or it's not stolen. So if the system is not stolen, then we are out our $225 premium. So we're paying that and that's gone. So our result is that we have lost $225, or negative $225. What if the system was stolen sometime during the year? Well, then the insurance company would pay us $2,000. But since we've already paid our $225 premium, the net result for us would be $2,000 minus $225. Or a net result of $1,775. And again, I get that by taking the $2,000 that the insurance company is paying us and subtracting the $225 that I have already paid for the premium. So that's my result if the system is stolen during the year. Now, to calculate our expected value, all we need to do is multiply each result by the probability of that result. So thinking through the values in the table is really the more challenging part of this. Once you have the table set up, then it's just a matter of multiplying each result by the probability, doing that on your calculator, and then getting an answer. So 1,775 times 0.1, and then plus negative 225 times 0.9, or you could say minus 225 times 0.9. And if you do that on a calculator, you should get negative 25. And so what happens here is our expected value as the customer is negative $25. So now we know that we're not actually going to be out $25. We're either going to be out $225 or we're going to have a positive result of $1,775, although obviously that means that our system was stolen and so we're out that too. But our expected value here is a negative $25. So that means that over, in this case, it would be over time, but also over everyone who's paying into the insurance. If we took the average result that everyone got, it would be negative $25. Now, looking at it from the insurance company's point of view, I have my same probabilities of the system being stolen being 0.1 and the system not being stolen of 0.9. But think about where the money is going. So if the system is not stolen, then that means my insurance company is taking in that premium of $225, and I don't have to pay out anything. So my result is a positive $225. If the system is stolen, I'm still taking in that $225, but I need to pay out $2,000 to the customer. And so my net result is $225 minus $2,000. And that's going to be negative $1,775. So for my expected value as the insurance company, it's going to be negative $1,775 times 0.1 plus 225 times 0.9. And if you do that on your calculator, you would find an expected value of positive $25. Now, the insurance company wants to have a positive expected value. That's how they make money, and that's how they cover their costs, pay their employees, pay for buildings and everything else. They need to have a positive expected value. And again, remember that's averaged over all of the people who buy the insurance over all of the years. So they aren't getting $25 from any single customer. They're either getting $225 or they're paying out $17.75. But averaged over everyone, they expect to get $25 per customer. And if they do not have a positive expected value, that's a problem, because that means that they are taking a loss on that insurance project, and as a business, you don't ever want to be taking a loss. So let's look at another problem here. This one is an outdoor concert. So they have an outdoor concert scheduled for outdoors, and they are worried about rain, as you might be with an outdoor event. And so they have a prediction that the chance of rain on that particular day is 0.24. If it doesn't rain, they are going to net $100,000. If it does rain, then the net will only be $10,000 because they won't sell as many tickets. People won't want to go if it's raining. And so we have an insurance company. They're going to insure the concert for $100,000 against rain at a premium of $20,000. Should we buy this insurance? So we're going to start by calculating the expected value for the promoter if we buy this insurance. This is the most complicated expected value calculation because we have to kind of consider all of the moving parts here. So we are purchasing the insurance. So that means we are paying $20,000 regardless of whether it rains or it doesn't rain. Well, let's start with the probability here. We know that the probability of rain is 0.24, and we know that the probability that it doesn't rain is 0.76. So, if it doesn't rain, we have paid $20,000 for the insurance, and it's not raining, so we're going to net our $100,000. So our net result is $80,000. We paid for the insurance, so that's negative $20,000. It didn't rain, so we didn't need to use the insurance, and so we netted $100,000 from ticket sales. And this is where, when it does rain, this hint comes in. If it rains, the promoter will receive the $100,000 payout plus the net from the concert. So if it rains, what happens? Well, we have paid for our insurance, so that's negative $20,000. We have our net from the ticket sales, which is $10,000. And we receive the payout from the insurance company, which is $100,000. So what is our result? Negative $20,000 plus $10,000 plus $100,000. Or altogether, when I add those three numbers up, I get $90,000. Now we need to calculate our expected probability. This is the easy part because we're just multiplying each result by the probability. So my result is 90,000 with a probability of 0.24 plus 80,000 with a probability of 0.76. Do that on a calculator and you should get a value of $82,400. So that's my expected value. Now again, I can't actually get that. If I buy the insurance, I'm either getting $90,000 if it rains, $80,000 if it does not rain. So question B says to calculate the expected value if we do not purchase the insurance. So we have our same two probabilities here, 0.24 if it rains, 0.76 if it does not rain. If it does not rain, then we are going to net $100,000. And we aren't buying the insurance in this case, so we're not paying that $20,000. if it does rain, then our net is only going to be $10,000. So that's our result. Now to calculate the expected value, it's going to be 10,000 times 0.24 plus 100,000 times 0.76. And do that on a calculator, you get $78,400. So in terms of answering the question, should we buy this insurance, we need to compare the expected values. Whichever one has the higher expected value is the one that I should do, because on average, that's thinking about how much I'm going to make. So looking at this, I see that I have a higher expected value when I buy the insurance than when I don't buy the insurance. So on a purely mathematical basis, I should purchase the insurance. Now, sometimes there are other things to consider in terms of insurance, and one of the biggest things is whether you could handle a large loss if you don't have the insurance. And that's why it is still important to have insurance, even though it's a negative expected value to the customer. So like in this example, I see that whether or not I buy the insurance, I have a good result either way. I'm either making $90,000 or $80,000. If I don't buy the insurance, I have about a 1/4 chance of only making $10,000. And so that's something that I also maybe would take into account in terms of whether I buy the insurance or don't. Obviously, people still buy insurance even if the expected value to the customer is negative, because there's other factors to consider. But from the expected value standpoint, the expected value is higher if the insurance is purchased. So that means that the promoter should purchase the insurance. Now let's calculate the expected value from the company's point of view. So if the promoter purchases the insurance and the company writes the policy as given, but we still have our same probabilities of rain and not rain. Probability that it rains is 0.24. Probability that it does not rain is 0.76. So from the insurance company's point of view, remember the premium is $20,000. So if it does not rain, they take in that $20,000, nothing else happens, and so they have a positive result of $20,000. If it does rain, they are still taking in that $20,000 premium, but now they have to pay out $100,000. So that's going to be $20,000 minus $100,000, or a net result to the insurance company of negative $80,000. And finally, to calculate the expected value, I'm just going to multiply each result by its probability and add them together. So negative 80,000 times 0.24 plus 20,000 times 0.76. Do this on your calculator, and you would get an expected value of negative $4,000. This is bad for the company. They should not underwrite a policy with a negative expected value. So somebody is getting in trouble for underwriting this policy because the net expected value for the insurance company is negative. And that means the insurance company, if they write many of these policies, they're going to be losing money overall. And again, companies do not want to lose money overall. That is bad for business.